All right, so welcome to tonight's lesson. We're still discussing trigonometry, we're still revising trig. So today we'll specifically look at equations. Yeah, so tonight we'll specifically look at trigonometrical equations. How do you solve trig equations? All right, so if you have any questions or you want to know anything about you want to know anything about how I conduct these lessons, you can simply just contact me using any of these lines on the screen. All right, so let's quickly begin. Yeah, so these are some of the trig equations that we're going to look at in the tutorial sheet. This is question 7. And then there's also question 8. It's also talking about trigonometrical equations. All right, so I'm going to start with question 7. Okay, so the question is solve for so in this case, we're solving for x, and then the answer that we're going to get should be in the range, should be in this domain that has been given here. So we've been given this as our domain, meaning the answer that we're going to get should be in this range here. Okay. All right, so let's, the answer that we're going to get should be in this interval. So the interval that has been given is from 0 to 2 pi. When you see anything that is written as 0 less x less anything this side, you can have 5, you can have 10, any number this side. It means that we're talking about numbers between 0 and 5. If there is this symbol less or equal to, it means that we're talking about numbers starting with 0, meaning 0 will be also, meaning 0 is also part of the set, and up to 5, and 5 should also be part of the set. That's what it means. So in case you want to know more about intervals, there's a video online which I can send to you. All right, so the first question we have here is this one. So the question is 2 cos x minus 1 is equal to 0. So how do you solve this question? So solving this question is simple. The first thing that you need to do is to write the equation of cos. So I'm solving a. So we have 2, then we have cos x minus 1 is equal to 0. So the way you solve this equation is you first take this one to the other side of the equal sign. Yeah, so meaning you're going to have 2 cos x being equal to positive 1. Then from there, I'm going to divide everything by cos x. So I'll divide everything by, I'm going to divide everything by 2, not cos x. Then we have cos x this side being equal to 1 over 2. So here now, it's a matter of us finding the value of x. So the answer that we're going to get here is not going to be the final answer. So what we're going to get is not going to be the final answer. The answer that we're going to get after solving this equation is going to be called a reference angle. So we're just going to use it as a reference to find the answers. So to find x, we're going to find the inverse of half. We're going to find the cos inverse of half. Yeah, so we'll say x will be equal to cos inverse of 1 over 2. So cos inverse of 1 over 2 is simply just 60 degrees. How do I know that it's 60? There's a video that I made about finding special angles, which I think I sent to the group. Yeah, so if you don't have it, you can simply just text me. I'll send you the video. Yeah, so cos inverse of half is 60. Yeah, so cos inverse of half is 60. Okay. So you have x is equal to 60 degrees. So this is just the reference angle. So this is not a final answer unless otherwise. So what do we do now from here? So we find the quadrant in which cos is positive. So the quadrant in which cos is positive. You look at the symbol, or rather the sign of what you have this side. So we have positive half this side. So we have 4 quadrants. We have the first quadrant where all the trig ratios are positive. Then we have the second quadrant where only sign is positive. Then we have the third quadrant where only tan is positive. Then you also have the fourth quadrant where only cos theta is positive. Yeah, so since the angle that we have this side is positive, it means that this trig ratio or this equation also lies, the solution of this equation also lies in the first quadrant, because in the first quadrant, all trig ratios are positive. So meaning our first answer is x is equal to 60 degrees because all trig ratios in the first quadrant are positive. Okay, so this is our first answer. Let us now look at the other answer. How do we get it? We also have to find another quadrant where this equation lies. How do you find that quadrant? So we said cos theta is positive in the first quadrant and in the fourth quadrant. So in the fourth quadrant, only cos is positive. So in the fourth quadrant, we know to say the equation that you use when you're solving an equation which is in the fourth quadrant, we say, okay, let me write some statement here. So we say in the fourth quadrant, so in the fourth quadrant, the value of x is found by subtracting the reference angle from 360. So we say 360 degrees minus the reference angle, which is 60 degrees. And hence the answer you get to be 300 degrees. So this is what we found as the answer. Yeah, so these two answers, you have to check if they are between 0 and 2 pi. Remember in radians, in radians, we said pi is equal to 180 degrees. So 60 degrees is simply just, so let's see, x is equal to, so 60 degrees can also be written in radians as what? If pi is equal to 180, so 60, we put our 60 degrees this side.
I'm flooding this paper.
So in cross multiply, you're going to have pi.
So here, the first one should have ECZ on it, shouldn't have this.
180.
The second one again should use same information, but yes, remove ECZ and put EEO.
What are these? They're like.
Okay. So when you reduce this, you find your value of x to be 1/3 pi. So 1/3 pi is between 0 and 2 pi. Hence, it's one of our solutions. Then we also find the other solution. We've also found this as our other solution. So how do we convert it to radians as well? So we put our 300 here. Then you cross multiply pi times 300 and x times 180, and then you make x the subject. Hence, you get something like this. So you have x is equal to 180 degrees over 300. Rather 300 degrees. Let me just over 180. Let me just write it properly. So we have 300 pi over 180 degrees. So when you reduce this, you're going to have, so when you cancel the zeros there, you get 30/18. Then reducing that further will give you 5/3. So you can find the number that can go into 30 and 18, which is 6. So you can just write 5/3 pi. So 5/3 pi, is it between 0 and 2 pi? Yes, the answer is yes, meaning this is one of the solutions, even this is one of the solutions. So we have two solutions for this equation. So you can try to put, if you want to prove that these are correct, you can try to put 60 degrees where there's x there, You can also try to put 60 degrees, 300 degrees while there's x there. You see if you're going to get 0 as your answer. That is how you prove an equation if it's correct or wrong. Okay, so we move on to the next one. Do you have any questions on this one? Or maybe let me just talk about what I said on this part. In the fourth quadrant, to find the value of that given trigonometric equation, you say x is equal to 360 minus the reference angle theta. And then here you just get that same theta as your answer. That's why we just got 60. And then in the fourth quadrant, you have to subtract the reference angle from 360. And then in the second quadrant, you have to subtract the reference angle from 180. So in the second quadrant, you say 180 degrees minus the reference angle. Then in the third quadrant, you say 180 degrees plus the reference angle. Okay, so let's quickly move on to the next question. So the next question is this one. So the next question is 2. So we are on part B. So we have 2 sine x cos x. Then we say plus cos x is equal to 0. So when you're solving such an equation, the first thing that you have to do is to look at the equation, the way the equation is. Then you analyze it. And then if you see anything that is common, make sure that you factor it out. Don't take this to the other side of it. Don't take this other cos to the other side of the equal sign, and then you divide by cos on both sides. That is the beginning of the error that you're going to make. So what you need to do, if you have anything common in the terms there, you factorize it out. So when you factor it out, we're going to have cos x. Then we open the brackets. Then we have 2 sine x. Then we remain with plus 1 in brackets, and then we say this is equal to 0. So here we have 2 equations which we can split and say the first one is cos x is equal to 0. Then the second equation is 2 sine x plus 1 is equal to 0. Okay, so here don't make a mistake by dividing everything by cos x. No. Okay, so from there we can solve both equations separately. Okay, so the first equation is cos x is equal to 0. So cos x is equal to 0 is our first equation rather. So to make x the subject, we're going to find cos inverse of 0. So cos inverse of 0. What is cos inverse of 0? The answer is 90. So now if you want, you can get the answer and convert it into radians. Or if you don't want, you can just you can simply just use it in the degrees, but make sure that your final answer is in radians, because the interval that has been given is in radians. Yeah, that's the reason why I converted the previous question into radians, the final answers of the previous question into radians. So cos inverse of 0, this will give us 90 degrees. So we can find where cos is positive, in which quadrants is cos positive. So we know to say cos will be positive in the first quadrant and in the fourth quadrant. So in the first quadrant, we know that all trig ratios are positive, hence we can get this as, we can just get 90 degrees as one of the solutions. So in radians, 90 is simply just 1 over 2 pi, or you can say pi over 2. And then from there, we can also find the other quadrant, which is the fourth quadrant. So in the fourth quadrant, we say, so in the fourth quadrant, we can simply just say the value of x is equal to, in the fourth quadrant, remember what I said, in the fourth quadrant, you say 360 minus the reference angle. Yeah, so you say the value of x will be equal to 360 degrees minus the reference angle. So the reference angle here is 90. So we can subtract 90 from that. So when you do the subtraction, we're getting, when you say 360 minus 90, you are getting 270 degrees. Then 270 degrees converted to radians, this will be 270 degrees. This will be 270 degrees pi over 180 degrees pi. This is the shortest form of converting. So when you divide that, this is just having 20. When you cancel the 0 there and that 0, I'm going to have 27 over 18. Then we know that 9 can go into 27 and into 18. So this will give us something like a 3 over 2 pi. Yeah, so this is what we have in radians. So we have found two answers for the first equation, which is cos x is equal to 0. So we also have to work out this independently. So let us do it separately. So we make sin x the subject. Hence, we're first going to start by taking this -1 to the other side of the equal sign. So we're going to have sin x is equal to, we want to have 2 sin x is equal to -1. Then we divide everything by 2, hence getting sin x is equal to -1 over 2. So whenever you have a negative here, you say let sin phi, you introduce another parameter there. So you say let sin phi be equal to a positive form of this number. So we have 1 over 2, positive 1 over 2. So we forget, we omit the negative. So from there we can find the reference angle. So how do you find the reference angle? We find sine inverse of half. So the reference angle in this case will be phi is equal to sine inverse of 1 over 2. So sine inverse of 1 over 2, this will simply just give us 0.5, which is just the same as 1 over, or sine inverse of 1 over 2 rather. This will give us 30 degrees. I confused the two. Okay, so this will give us 30 degrees. So this will give us 30 degrees. So this is not a final answer. This is just the reference angle. So we can find the answers now. So we need to check in which quadrant is sign negative. Now you can consider the sign of this number that is this side on the right side of the equal sign. So you look at its sign. So its sign is negative there. So you say, in which quadrants is sign negative? We know to say sign is positive in the first quadrant. It's also positive in the second quadrant. It's also positive. So sign is also positive in the second quadrant. In the third quadrant, only tan is positive. In the fourth quadrant, only cos is positive. So you can master this by using a mnemonic word or a mnemonic sentence where you say, all students take calculus. All students take calculus. If that's if you don't want, you can just master it, maybe going the other way around like this. When you read it, starting from A, going to the clockwise direction, it reads as the Bible, what's this? Acts. Yeah, when you look at Acts, this is the Bible book. Yeah. So this is the other way you can master this. Yeah. Or if you want, you can just say all students, when you are going this side, you can say all students take coffee, or all students take calculus. Still fine. So we know to say this is the reference angle, and then we need to find the final answers. How do you find the final answers? We check in which quadrant is sign negative. So sign is positive in the first quadrant and in the second quadrant. So we expect sign to be negative in the third and fourth quadrant. So in the third quadrant, the final answer, which is the value of x, will therefore be equal to. So remember what I said, in the third quadrant, you have to say 180 degrees plus the reference angle. So x will be equal to 180 degrees, or if you don't want to use 180, if you just want to use radians directly, you can just say pi, because 180 is just equivalent to pi. It's actually equal to pi in radians. So you say 180 plus the reference angle here is 30 degrees, which gives you what? So this will give you 210 degrees. When you convert this to radians, you get something like, you say x is equal to 210 over 180, then you multiply everything by pi. Then you reduce this. So you can reduce it. This in radians, it will be, so we know that 3 can go into 21 and also into 18. Into 21 goes there 7 times, into 18 goes there 6 times. So this is in radians. Yeah, so this is in radians. So this is our first solution, which is also between 0 and 2 pi, because we know that 2 pi is simply just the same as 2 times 180, which is 360. So when you talk about from 0 to 2 pi, it's just the same as saying from 0 to 360 degrees, because pi is equal to 180. And then the other quadrant where we said sign is negative is the fourth quadrant. So in the fourth quadrant, you say 360 minus the reference angle. So in the fourth quadrant, we're going to find x by saying x is equal to 360 degrees minus the reference angle, which is 30 degrees. And this will give us what? 330 degrees. So in this question, you have 4 answers. You have this one, you have that one, you have 210, you also have 330. Yeah, so if you want, you can convert them to radians and get your final solutions in radians. Yeah. Okay, so do we have any questions on this one, if I can proceed? All right, so let's quickly move on to the next question. So the next question is this one. Okay. All right, so the next question is this one. I wanted to skip some questions, but what I've discovered is, I think almost all the questions there, they all have at least one trick concept which you need to learn. So meaning we obviously do almost all the questions. Okay, so the next question is this one, which is 2 sine 3x, and you say minus 1 is equal to 0. So what you do is you take this, you take this negative 1 to the other side of the equal sign, so that you have sine 3x is equal to 1. And then you divide everything by 2, so that you get sine 3x is equal to 1 over 2. But remember, we have 3x there. Now, how do we deal with that? So we quickly say, let 3x be equal to 5. Yeah, so we're going to have sine phi being equal to 1 over 2. So we find the reference angle. So the reference angle will be found by finding the sine inverse of 1 over 2. So phi will therefore be equal to sine inverse of 1 over 2. This is 30 degrees, which can also be written as 1 over 6 pi in radians. So this one, I'll solve it in radians. Let me not even use 30 degrees. I'll solve it using radians, so that you can also get used to using radians without using degrees. So this one, sine inverse of 1 over 2 in radians is 1 over 6 pi. And then the other thing is, after finding the reference angle, we can now find the quadrants in which sign is what? Is positive. Because when you check the sign of this number here, it's positive. So in which quadrants do we have sign positive? So we know that in the first quadrant, all the trig ratios are positive. In the second quadrant, only sign is positive. In the third quadrant, only tan is positive. And then in the fourth quadrant, only cos is positive. So we quickly now conclude to say sign is only positive in the first and the second quadrant. So we can now say in the first quadrant, we know that phi will be equal to what? The same reference angle, which is 1 over 6 pi. This is our phi. And then remember that phi is equal to 3x. So meaning while there's phi there, we can replace with 3x. So we say 3x is equal to pi over 6. 1 over 6 pi is just the same as pi over 6. So when we divide everything by 3, divide everything by 3 on both sides, we get the value of x as pi over 1 over 6 divided by 3, we're getting 1 over 18 pi. So this is our first solution. Let us also find the value of this same, the value of x in the other quadrant which we picked, which is the second quadrant, where sign is positive. Hello?
I have a question.
All right, you can ask, please.
Why are we letting 3x equals to pi?
We just want to simplify the way. Okay, I just want to simplify things in short. If you want, you can solve it the way it is, but make sure that as you are solving, you don't use 3x in the process at any point. The only point where you are allowed to use 3x is after finding the reference angle. And then after finding the reference angle, you quickly come and do what? You quickly come and equate it to 3x. Yeah. If you want, you can do that. Yes. But the easiest way, if you don't want to make a mistake, first let it be equal to any variable. You can use phi, you can use x, you can use y, you can use z, anything. Yeah, so that you don't get confused in the process of solving, because there are some trig equations which are more complex than this. If you don't do this, you end up getting confused at one point as you solve. Okay, so in the second quadrant, the value of phi is equal to what? Remember what I said, in the second quadrant, you say 180 degrees minus the reference angle. And then in the third quadrant, we said this is 180 degrees plus the reference angle. And then in the fourth quadrant, we have 360 degrees minus the reference angle. So in the second quadrant, we're talking about the second quadrant in this case. So in the second quadrant, it's 180 minus the reference angle. So we say 180 degrees. But remember, I said I'm going to be using what? Radians. So 180 degrees is equal to pi in radians. So this is just the same as saying pi minus the reference angle. Yeah, so we say pi minus the reference angle that we have is 1 over 6 pi. So we put 1 over 6 pi there. Yeah, so when you do the mathematics here, when you simplify, you are getting the value of phi as 5 pi over 6. Yeah, so you're getting the value of phi as 5 pi over 6. But remember, phi is equal to 3x. So you put 3x where there is phi there. So we put 3x there. Then we say this is equal to 5 pi over 6. Yeah, so we can divide everything by 3 to get the value of x. Hence, this will become 5 over 18 pi. And to write the final answers, you say, therefore, x is equal to, you start with the smallest one. So the value of x, which is the smallest, I think it should be this one, 5 over 18. So we say 5 over 18 pi, comma. Then we also have another one, which is 5 over 6 pi. So after writing these, when writing these final solutions, you always have to make sure that the answers that you are writing are all in this given domain, rather the given interval. Yeah, so you have to make sure that everything that you found is within that interval. And this is what I found here. Okay, so as we can see, it has already started counting down. And as a result, I may end the meeting anytime. Then we'll use the same link to join so that we finish up the equations. Okay, so this one is also simple. So how do we deal with such an equation? Okay, for this one, I'll come and solve it in the next session. I wanted something that is simple and straightforward so that I do it quickly. Okay, which one can we solve? Okay, let me start this same one. So I'll just show you the way to solve this. So we have 2 sine squared x minus cos x is equal to 1. So you have to convert this to be in terms of cos by using the Pythagorean identity. So we know that the Pythagorean identity is simply just sine squared x plus cos squared x is equal to 1. So you make sine squared x the subject of the formula, and you have sine squared x is equal to 1 minus cos squared x. So while there is sine squared x there, I'm going to replace with 1 minus cos squared x. Hence, I'll have an equation which will look like this: 1 minus cos squared x in brackets, and then we say minus cos x is equal to 1. So when you once it's open the brackets there, you have 2 minus 2 cos squared x minus cos x is equal to 1. So when you look at this equation, you can agree with me that this is a quadratic equation. So we have negative 2 cos squared x, then minus cos x, then we have this 2 there, plus 2. Then we can take this one to the other side of the equal sign so that it becomes minus 1 is equal to 0. And then when you divide everything by, okay, before we divide, let me just write the equation properly. So we have cos squared x minus cos x. Then we have 2 minus 1. 2 minus 1, the answer is 1. So we have plus 1 is equal to 0. So if you want, you can divide everything by negative 2, negative 1, so that you have 2 cos squared x plus cos x minus 1 is equal to 0. Or you can just solve it the way it is, which is even just it is even better. Okay. So let us quickly begin to solve the equation. So this one is straightforward. As you can see, this is a quadratic equation. So you can therefore say let y be equal to cos x. So when you say let y be equal to cos x, this means that while there is cos x, you're going to replace with what? You're going to replace with y. So while there's cos x, you're going to replace with y. And hence this will be negative 2y squared minus y plus 1 is equal to 0. So this is a quadratic equation which you can solve using any methods that you know. So the product here is negative 2 times 1, which will give us negative 2. The sum is the coefficient of y there, which is negative 1. So do we have any two numbers that we can multiply to give us negative 2? When we add them, they will give us the sum, which is negative 1. Yeah, so these numbers are called factors. So these numbers are negative 2 and positive 1. So when you add negative 2 and positive 1, you're getting negative 1. When you multiply them, you're getting negative 2. So we replace them in the equation there. We're going to have negative 2y squared. Then we have negative 2y, positive y, then plus 1 is equal to 0. And then from there, we can now say, we can now solve the quadratic equation, which is easier. Say negative 2 is common, and this will be, negative 2y is common. And then when you factorize there, you're getting y, and then plus 1. Then you say plus 1 there, then y plus 1 there. Whenever you're solving a quadratic equation, you have to make sure that what you've gotten there is the same. Then when you factorize this, you're getting y plus 1, and then negative 2. So the time is almost up. So I'm going to, we should join using the same link. And the link of this, the link of the next video, I'll put it in the description in case of revision, or you want to go through the solutions of this question, of these questions. So I'll put the link for the part B, for the next part of this video, in the description. So this is what we have. Then you say plus 1 there, then you close the brackets, which is equal to 0. And then, so you equate this and that to 0 so that